Hello, in this video we are going to work quiz number 2, Ohm's Law, for class EE1305 at UTEP, and that was in the week of September 16th. And the problem asks us, using Ohm's Law, A, calculate the equivalent resistance, R equivalent, B, find the total current I, C, calculate the voltage drop for R2 in the circuit below, and D, calculate the power absorbed for R1 by 4, right? So you can see here, by R1, see, I make mistakes, right? And of course, show all units and unit conversions using the format taught in class. Okay, so what do we have here? We have a circuit here. We have a 12 ohm resistor. R3 is 10 ohms, R2 is 8 ohms, and R1 is 6 ohms. We have current in that direction. So with equivalent resistance, these are all in series. We know that in series, R equivalent is going to be equal to their sum, so it's going to be equal to R3 plus R2 plus R1, right? So if we do that, we can see that R equivalent is equal to 10 ohms plus 8 ohms plus 6 ohms. 18 says R equivalent is equal to 24 ohms, and that's part A. Keep it on right here and wrote that R equivalent is equal to 24 ohms, like that. Okay, so this is part A. Now, part B asks us to find the total current. Okay, so the total current then, what do we know? So if we have this, what do we have? So we have this situation here. We have 12 volts plus minus. We now have R equivalent equal 24 ohms, and we have I here. So the total current, I, is going to be equal to the voltage here divided by the equivalent resistance there. So that's going to be equal to 12 volts using Ohm's law divided by 24 ohms, right? 12 there says that I is equal to 0.5 amps, right? I is equal to 0.5 amps. Okay, so that's part B. Part C says C, calculate voltage drop for R2, right? So the voltage drop for R2 here. So now we know that if we have Ohm's law tells us that V equals IR. So in this case, the V for R2, this will be for R2 there. So that's going to be equal. And since we know that this is in series, that the only one current path, so the same current flowing through all of these resistors. So now we can go here and say, okay, that's going to be equal to 0.5 amps times, and the value of R2 is 8 ohms times 8 ohms, right? So 0.5 times that says that VR2 is equal to 4 volts, right? So we can write that over here. It says that VR2 is equal to 4 volts. Underline it. And finally, we calculate the power absorbed by R1. This is R1 here. So we know that P is equal to IV, right? So P is equal to IV, and we can substitute Ohm's law, which is equal to V squared over R, which is equal to I squared R, right? So here, because we want the power for R3, I would like to use my resistor because that's convenient, and I already know the current because it's the same. So I'm going to select this one. So it's going to be equal to I squared times R3, which is equal to 0.5 squared times 6 ohms, right? So that's going to be equal to 0.25 times 6, which is going to be equal to right, 1.5 watts. All right, so we now get the power through R3 is equal to 1.5 watts. All right, so this has been quiz 2 of this semester, Ohm's law. I hope this is helpful. The most common things, important things to know here: know Ohm's law, knows your power relationships, right? Know your series circuit in this one, and then make sure you're very careful, right? R1, R2, R3. In this case, you see some people, oh, this must be R1 the first one, but R1's down here. So take your time, make sure you label carefully, and you'll do great. Hope you like this video. Please feel free to subscribe, like below, leave a comment. Have a good day.